Today we'll be building a wind-powered electronic generator. First, the electromagnet. We gotta hammer in this nail.
Good.
And voila, we'll get this, a key component to our generator. The wheel will spin the magnets, changing the magnetic fields throughout the device and causing electron flow. Now we have our famous rice mill, very healthy for you and very useful for making this.
This is the most important piece to our wind turbine generator.
And now with our magnetic copper wire, all we have to do is wind it up around the box, and wind it up, and wind it up, and wind it up some more, and then finally wind it up. And there you go. The more wire you wrap around the box, the stronger the current created by the device.
We purchased strong rare earth magnets from a hobby shop. On the right side, we placed one negative side facing a positive side. As they slowly move towards each other, we can see that they attract. Meanwhile, on the left side, as both sides have the same charge, they repel. Next, we put all these pieces together. Taking the wheel we previously made, we attached magnets on it, making sure that the magnets on the same face have identical charges. We pierced the nail through the box and again through the wheel, and out the other end. The wheel can now freely spin in the box.
By hooking each end of the copper wire to a voltmeter test lead and spinning the nail to which the magnets are affixed, we are able to observe a faint yet measurable current. Right now, it doesn't exceed half a volt.
Next, to build the wind turbine. First, we sanded a dowel which will act as the support of our wind turbine. The light, flexible structure of pop bottles make them ideal for this turbine. We cut 2 pop bottles in half and hot glued them to semicircles of masonry board. Then, we drilled a hole through the center of the top and bottom. We made 2 of these to capture more wind.
We then assembled the turbine by placing the dowel through the pop bottles.
And now we're ready to build the base.
Next, we built a base out of wood and nails to support our turbine and generator.
Alright, now let's sand the base. Sanding the base makes it look pretty and removes splinters.
We then drilled 2 holes, one small and one large, through the structure's top.
The base needs to be built wide and sturdy as it reduces the chances of our device falling over.
Now we're all ready to put it together.
We secured a concave dome onto the bottom of our base. This plastic piece acts as a smooth surface for our wind turbine to spin on. We then spray lubricant throughout the main component of our generator in order for it to spin better. After placing our wood block supports in position, we glue the box onto the base. We made sure that the gear on top of the nail sticks out so it can interlock with the gear from the wind turbine.
Then we placed a large connect gear at the bottom of the wind turbine.
We stuck our wind turbine through the hole we previously drilled and voila, our device is complete.
Once again, we attached the wires to the voltmeter to make sure that our device is still generating electricity after being glued onto the base. As you will see, the generator is still working.
To test it out, we hooked the ends of our copper wire onto a galvanometer. Using a hair dryer to simulate wind, we got our wind turbine spinning. Consequently, that caused a chain reaction and spun our generator. As you can see, we can observe a current going through the galvanometer.
Now, how does this device work?
First, moving air causes the turbine and shaft on which a large plastic gear is fixed to rotate. The teeth of this gear interlocks with those of a much smaller gear, which is glued to the end of an iron nail. This ferrous core greatly increases the magnetic flux produced in the 4 rare earth magnets attached to it.
To maximize our generator's EMF output, we wrapped many turns of fine copper wire onto our armature, a repurposed rice milk container. This increased N, or the number of wire loops. We also used 4 neodymium iron boron magnets, which are the strongest permanent magnets made, to increase B.
Nothing will happen if the magnets stay stationary, as the magnetic field will not change. Therefore, we spin the magnets, changing the magnetic field. This produces a current which travels through the copper wires and into a load or galvanometer at the other end. Like all electromagnetic generators, our simple machine relies on the principles of electromagnetic induction to produce current. The poles of the magnets inside are arranged to maximize this. Those on one side of the cardboard have their north poles facing outwards, while those on the other side have their south poles facing outwards. This makes them act almost like one big magnet. The Faraday-Lenz law states that EMF, or voltage, generated equals -1 times the amount of turns in the wire coil times the magnetic flux, or the external magnetic field, times the area of the coil over the change in time.
In other words, if you were to graph magnetic flux versus time, the slope of the line plotted would equal the electromotive force, or voltage, produced.